This is lesson 15, rational expressions. So let's talk about rational expressions, okay, what they are in general. We'll do a little bit with the functions today, but really just want to talk about the expressions. Okay, so let's get to some. A rational expression is the quotient of two polynomials. Okay, so that's pretty much the definition we'll use. So you may have a polynomial on the top. You may have a polynomial on the bottom, right? That together makes a rational expression. Okay, and we're going to focus on these. And we're going to get to rational functions. I think that's the second half. All right, so let's talk about simplifying a rational expression. So here we have x squared minus 9 as the numerator and x squared plus 4x plus 3 as the denominator. I want to simplify this. So usually what you would do is just factor the top and the bottom, right? Just factor and see if anything divides out. It's kind of like if you're trying to simplify something like a number, right? 9 over 6. 9 is 3 times 3 if I think about the factors. 6 is 2 times 3. 3 divided by 3 is 1, so it's just 3 over 2 times 1, or just 3 over 2, right? So that's simplifying a fraction. We're going to use that exact same idea, that concept, to simplify this rational expression here. So I'm going to factor it. Hopefully by now you recognize the numerator x squared minus 9 is difference of squares. So x plus 3, x minus 3, right? Where x and 3 come from the square roots of these right here. That's the numerator. The denominator can be a little bit trickier, but this is one that you can do just by looking at it. So x and x because x squared. 1 and 3 because 1 times 3 has to be 3. And if I add those together, 1x and 3x, those add together to be 4x, right? So that actually worked out pretty easy. There was not a lot of options there. Okay, so there we go. We simplified it, or we factored the top and the bottom. Now we'll simplify by saying x plus 3 and x plus 3, top and bottom, those two divide out, right? That's just 1. And so we're left with x minus 3 over x plus 1. So there's the simplified expression. Now I do need to point out that these two are not exactly equivalent, right? They're almost equivalent, but they're not exactly the same thing. Okay, well, why is that? Okay, well, think about the first one here. Think about what numbers you can plug into it, right? You can plug in anything except for a -1, because that would make this bottom denominator part right here, this right here, 0. And this right here, you can't plug in -3 because that would give you dividing by 0 again. So this first one is not the same as this one right here, because this one I can actually plug in -3. That would be fine. There's no restriction in the denominator there. Okay, and so you would say that this one right here is the same thing as the original, except when x equals -3. Okay, now usually you just leave that part off. You don't have to actually include that most of the time in the solution whenever you're working this out. But that is something to keep in mind. They're not the same thing. I do want to show you, I can verify this graphically. Okay, so here's the first example. Here's the first expression here, and you can see here's the graph. Here's the graph of the new one. I make a sharper contrast here. Okay, so here's the simplified version. They look exactly the same, right? But you'll notice something different here. On the blue one here, when x is -3, there we go, -3. When x is -3, look what happens to the y value. It is undefined, right? There's literally a hole in the graph right there. So there's no graph there. However, if I look at the red one and I look at -3, it is defined there. There's a point there. It's part of the graph. Okay, so the graphs line up everywhere except for at that point. So that's what this statement at the bottom here, except when x equals -3, that's just a clarifying statement. Okay, anyway. Let's multiply these two rational expressions. What you don't want to do is start distributing, right? You don't want to do all of that. That's going to be too complicated. Instead, factor the top, factor the bottom of each one. Okay. And then we're going to write it as one big fraction. So let's focus on this one first. X squared plus 4x minus 5. Okay, the first number has to be, or the first term has to be an x in both of them, because that's how you'll get x squared. One of them has to have a 5, one has to have a 1. And because it's a negative, it has to be a positive and a negative. So we'll make the 5 positive and the 1 negative. I'll check it really quickly. 5x negative 1x. If I add those together, I get positive 4x, which is the middle term. Okay, so I can hurry up and check it real quick, make sure that I factored it correctly. Okay, this one here is just 2x minus 1. Okay, down here at the bottom, 3x plus 18. I can factor out a 3, common factor of 3. 6 times 3 would give me the 18. And then this x plus 5 right here, nothing can be factored out, so x plus 5. All right, so I put this as one big fraction, right? Now let's see if anything cancels out. The x plus 5 on top and bottom would cancel. And that will leave me with x minus 1, 2x minus 1 over 3x plus 6. So there we go. That is simplified. I do want to clarify though, except when x is equal to -5, are these the same? So x minus 1 times 2x minus 1 over 3x plus 6. Okay, here's a division problem. We'll work this one out also. So with division, remember, first of all, when you divide by a fraction, let's go back to our example here. You divide by a fraction, let's say 4/5. You just multiply by that fraction's reciprocal. Okay, so you flip the fraction over and then you just do multiplication. So same thing is true here. We're going to do the exact same thing. 2x squared plus x minus 6 over x squared minus 1 times x squared plus 2x plus 1, right? The denominator here, divided by x squared minus 4. Now I'll treat it just like the last problem, right? I will just make one fraction, factor the top and the bottom for each part. Okay, I'll do this one in red. So 2x and x will go there and there. Okay, they have to multiply together to be a -6. So I have to kind of guess what I'm going to put. So maybe I'll put 3 here and 2 there. Here's a little tip. If you're factoring something and like my options are 2 and 3, since this one already had a 2, I'm not going to put the 2 there, because then there's a greatest common factor that can be taken out, in which case there'd be a 2 out here, and that actually just makes the problem more complicated. So just don't put it there, and it usually works out. Okay, so 2x, x, 3, and 2. One of these has a positive, one has a negative. Let's see if that's right. 3x, -4x. If I put those together, that gives me a -1x. Okay, I need it to be a positive 1x. So that means that my signs are backwards. Okay, anytime you work this out and this comes out to be the wrong sign as this one, different sign, that just means your signs were backwards. So just fix the signs, replace them. So this is going to become a minus and this is the plus. Okay, now let's factor in blue this one here, x squared plus 2x plus 1. You have to extend that fraction bar. Okay, we have x and x. And all we can put here is 1 and 1. And that one will work out. It's 1x, 1x, add them together, you get 2x. That's an easy one. Okay, now on the bottom here, x squared minus 1 is difference of squares. So we have x plus 1, x minus 1. Remember, that's just the square roots of those. And then x squared minus 4, difference of squares again. So x plus 2, x minus 2. Okay, a lot of factoring going on. All right, so now the fun part is to go through and see what cancels out. I see that x plus 2 can cancel out with an x plus 2 down there. I see an x plus 1 will cancel with an x plus 1 down there. So I'm left with 2x minus 3, x plus 1, x minus 1, x minus 2. Moving on. Let's add the rational expressions here. So we did multiplying and dividing. Here's addition now. Remember when you add, like 4 thirds plus 5 halves, you have to find a common denominator, which in this case would be 6. So you would do what you had to do to make this over 6. Well, what you can do is look at what this denominator has that this one doesn't have. It has a 2, right? An extra 2. So I would have to include a 2 and have to put it on the top and the bottom to make this fair, right? Because 2 over 2 is just 1. This one's missing a 3, so I'd put a 3 and a 3. And again, I think about that as a fraction because that's just 1. And that would give me 8 over 6 plus 15 over 6, which I can add together and get 23 over 6, right? Same idea, same exact thing's going to apply here. I'm looking at each of these, and I'm asking, what does this denominator have, or what does this denominator have that this one does not? And that would be an x minus 3. So, okay, I will include, let me just extend my fraction bar a little bit. I will include x minus 3, x minus 3. Now, just to be careful, I'll put x plus 1 in parentheses because that was all together, right? That was one denominator. So I want to keep it together. Okay, I'll do the same thing over here. What does the other fraction, what does this one have that this one doesn't? That would, of course, be x plus 1. So by including that in each of those, now they have a common denominator. Of course, notice the order is different, but the order doesn't matter, right? Multiplication is commutative, so it doesn't matter what order you put them in. Okay, so that's 4x minus 3 plus 5x plus 1, all over the same denominator, x plus 1, x minus 3. Or you could put x minus 3, x plus 1, either way. Let's distribute the 4. Distribute the 5. Denominator will stay the same. Why did I distribute the top but not the bottom? That's because you had 2 terms that were being added together, right? That's the reason. Okay, and so 4x plus 5x would be 9x. Negative 12 plus 5 is negative 7 over x plus 1, x minus 3. Okay, here's a subtraction one. Of course, you want to factor. Same exact idea as what we just did a second ago, except we're going to subtract them this time. Okay, x and x. They have to multiply together to be 4. So my good options would be either 1 and 4. If I add those together, those add up to 5x, not 4x. So 1 and 4 is no good. What about 2 and 2? 2x, 2x, add it together is 4x. That's what I needed. Okay, good. I liked a little bit of review of factoring. Okay, and then over here, x plus 2, x minus 2. I don't think much about that. I recognize it as difference of squares. You see it so often. Okay, so again, you have to look at what does each denominator have that the other does not. Okay, and so give myself more room to write this out. This one has x plus 2, x plus 2. This one has x plus 2, x minus 2. Okay, well, over here, I need to fill in an x minus 2 because that's what this one has. Over here, I need another x plus 2. I only have one, but I need two x plus 2s. Okay, but of course, you can't just put it on the denominator without adding it to the numerator. Okay, there we go. So now from there, let's put it all together as 1 minus 2x plus 2 over x plus 2 twice. So I'll put a squared here, x minus 2. Okay, the denominator, I can leave that alone, but the numerator, look at that. We have two terms separated by a subtraction symbol. So let's distribute the 6 and the 2. Minus 2x minus 4, right? That minus sign carries over. Over x plus 2 squared, x minus 2. Six x minus 2x would give me 4x. Negative 12 minus 4 is negative 16. Over x plus 2 squared, x minus 2. Now this, I can see I can factor out a greatest common factor. If it's noticeable, you should factor it out, right? Because you may end up canceling out something on the denominator, canceling out even further. So I see it's divisible by 4, so factor out 4. And as much as I want to cancel that out with something in the denominator, I cannot, right? X minus 4 doesn't cancel with any of those x plus 2s or x minus 2. So this would be simplified. So this one is one problem I wanted to go over because it looks different. But what you should do is notice you have a fractions over fractions, right? The denominators here, the common denominator there would be 6x. Compare that to this one, 6x is also a common denominator for that. If you look at all three denominators together, the common denominator would be 6x. So I'm going to multiply the top and the bottom of this fraction by 6x. I distribute 6x times 3 over x would be 18x over x. 6x times y over 6 would be 6xy over 6. 6x times 2y is 12xy, and that's over 3x. Okay, this doesn't look nicer until you start simplifying these, right? So let's simplify them. X and x cancel. 6 and 6 cancel. X and x cancel here, and 12 over 3 becomes 4 over 1. So I'm left with 18 plus xy over 4y. And this one I got from Alex. I changed the numbers around, but I got this one from Alex, okay? So this is one that you should definitely practice. It says find the least common multiple. Don't confuse that with the greatest common factor. Okay, the first time I worked this problem out, I just assumed greatest common factor without reading it. And so I got it wrong, right? Least common multiple. That's like saying the common denominator if these were denominators, right? If these were under something, then that'd be the common denominator. Least common multiple. Okay, so how do I figure that out? Let's do these one at a time. 4x squared y to the fourth z cubed is the same thing as 2 times 2, right? That's 4 times x times x times y times y times y times y times z times z times z. Okay, this is the long way to do it, but it works, okay? And once you understand this method, you can of course shorten it. Okay, for the second term, we have 5, we have 4 x's, and we have a z. So to find the common multiple, I need to look at each grouping and make sure I have everything covered from both of them. So for the first grouping, there's 2 2's and a 5. For the x grouping here, the bottom one has 4, the top has 2. So whichever one has more is what I'm going to go with. There's 4 x's in the bottom one, so I'm going to go with 4 x's. Okay, if I went with the 2 x's, then I'd be excluding 2 x's, right? So I want to go with those. This one has no, the bottom one has no y's, so I need to make sure I include the 4 y's from the top. And then the last one, we have 3 z's on top, 1 z on the bottom. So which one has more? The top. So I will include all 3 from the top. Okay, so my greatest common multiple, or I'm sorry, my least common multiple would be 2 times 2 times 5. 2 times 2 is 4 times 5 is 20. X to the fourth, because I have 4 x's. Y to the fourth, because we have 4 y's. Z to the third. And that would be my least common multiple. All right, so that is this section.